So let's do a little review of how we found the equation of a secant line in pre-calculus. And then we'll see how can we put our calculus to work to get the equation of a tangent line. Okay, so you'll probably pause, write that down. All right, so first thing that I did is I want to look at, well, what is this graph? This is a parabola. It's opening down. The 4 is going to make it go up. The 2 is going to make it a little bit skinnier. Okay, so the graph looks like that. Okay, and I'm trying to find the secant line that goes through 0, f of 0, and 2, f of 2. So we often don't have the graph. I like to use the graph at first so you can kind of ground yourself on what you're doing. So I want to find these 2 points. So I need to find f of 0. Well, if I plug 0 in, I'm going to get 4. And I'm going to find f of 2. So that would be 2 squared is 4, negative 8 plus 4 is negative 4. Okay, so in a very complicated way, all they're asking me to do is find the equation of the line that goes through 0, 4, and 2, negative 4. That's it. That's all they're asking. We did need to know the equation. So let's see, in order to get the y values. Okay, there's 0, 4, and 2, negative 4 is right there. Okay, they just want the equation of this line. Let me make it in a different color. So again, normally we don't have a graph, but I want you guys to see that I'm just doing math 1 here. Okay? Well, we know how to write an equation of a line. So, but I want you to start thinking that we're finding the slope of the secant line. Okay? And it's just regular old slope like you've always done. So I'm going to go negative 4 minus 4 over 2 minus 0. And that is negative 8 over 2 is negative 4. Well, let's look if that's reasonable. Yep, 1, 2, 3, 4 over 1 sure is. Okay, we use point slope formula. Y minus y1, I think I'll use this equation right, or this point right here, equals m, x minus x1. So y minus 4 is negative 4x. And I know normally we said you could go ahead and stop there, but I'm just checking this. Okay, that looks like the equation of that line. Yep. Okay, now back in pre-calculus, that was like hard. Okay, see how far you've come already in a month? That was kind of hard. Okay, so now we're going to change it up. And now what I want you to do is I want you to find the equation of the tangent line. And we're going to look for that at the point 2f of 2. Okay, so this is a little bit different because we can't just get the slope very easily. We have to use a limit in order to get the slope of the tangent line. So the tangent line is going through this point right here. And remember, it just touches the function right, barely right there. So I'm just going to eyeball it. So I don't know. It looks like maybe something kind of like that. Okay. So I'm finding the equation of this line right here. Now, this line only touches in one place, right at that point. So I don't have 2 points to find the slope with. Okay, so what I need to do is I'm going to use my formula that says, all right, if you want the slope of the tangent line, you're going to have to take the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, and we practiced that a lot in pre-calculus. We didn't put limit in front of it, but we practiced using this. All right, so let's go ahead and let's try it. So the limit as h approaches 0. So I have to go to my f function. And everywhere I see an x, I'm going to plug in an x plus h. Okay, so let me just put it right here so we remember that it looks like this. Okay, so I have to go -2, but instead of x, I'm going to put in x plus h squared plus 4. Okay, then I have to subtract f of x. Now, pre-calculus students always forget to put that parenthesis there. Don't forget to do that. Otherwise, you're going to be totally wrong. Okay, so now I'm going to do some algebra. So I'm just going to work on the top. So I'm going to leave that alone. I'm not going to have that here because I'm just doing some algebra. Okay, so I have -2. This would be x squared plus 2xh plus h squared plus 4 plus 2x squared minus 4. Okay, so that's -2x squared minus 4xh plus h squared plus 4. Okay, let's see what's going to cancel out. That's going to go with that. That's going to go with that. Okay, so let's see. Now I'm going to go back to my problem. I have to put that limit back on because I haven't found that limit yet. And we have -4xh plus h squared. Now, I know that if I tried to do direct substitution right now, I would get 0 over 0, which would be the indeterminate form. So I'm going to factor. And I'm going to take out an h. So this is the limit. Now, again, I'm not plugging in my 0, so I have to have this notation right here of h times -4x plus h over h. So that would cancel out. So now I'm trying to find the limit as h approaches 0 of -4x plus h. Now I'm going to plug in my 0. Well, when I plug in my 0 for h, oops, that's a 0, so it just equals -4x. Okay, that would actually give me the slope of the tangent line anywhere. Anywhere I could plug in any x value. But I'm going to say when x equals 2, the slope of the tangent line is -8. Okay? So if I think about my paper to say, does this make sense? Oh, there we go, over here. Yeah, I think that makes sense, that it's pretty steep, that the slope would be -8. Okay, but I still didn't find the equation. So what I'm going to do, I'm going to get another piece of paper, and I know the slope, and I know a point. So now I'm back to Algebra 1, or Math 1, whatever we want to call it. Okay, let me set up my paper here. So I know that my slope of the tangent line is -8. And I know that it goes through the point 2f of 2. And we already found f of 2, right? We said that was -4. Okay. Y minus y1 equals m. X minus x1. Y plus 4 is negative 8x plus 16. Y equals negative 8x plus 12. All right, let me see. Okay, so I'm going to put this on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we said it should go through that point and have a slope of negative 8. So 1, 2, 3, 4, 5, 6, 7, 8 over 1. Ooh, I was pretty close. Okay, let's do 1, 2, 3, 4, 5, 6, 7, 8 over 1. Oh, you guys couldn't see that. That's the point that I wanted. It's there. So the tangent line actually looks like that. Kind of hard to see. Okay. Another thing that I like to do is let's just check it. Yeah. Let me get another computer over here. And let's just look at Desmos. And hopefully you guys can see that. Okay, so here's the equation. Okay, let's check our secant line. We said that our secant line, the equation for that was y equals, might have put a capital Y. I don't know. Let's check and see if it's going to work. So y equals negative 4x plus 4. That isn't going to work. Hold on, you guys. I can put this in. I know I can do it. Probably going to take me forever because I'm not used to this computer. Okay. Let's go. Y. Oh man, it's a pain in the butt on this computer. Okay, I'm not going to do it. There you go. I'm not going to do it because it's a pain in the butt. You guys can put those in to Desmos on your computer and see that they all work. Okay, so we did it. There's the equation of the tangent line. Okay, so what you guys are going to do for homework, the worksheet that I put in your packet that I, of course, cannot find right now. It's the end of the day, and everything's mixed up. Okay, it has the two graphs on it that I showed you guys this morning, which of course are nowhere to be found. So you're going to look in that packet that has those two graphs, and I'm still looking for them, and I might find them. I did it. Okay, so it says that this is one we did in the notes. We didn't do this in the notes. I picked a different one. Okay, so I want you to do what we just did using this equation, and I have the graph for you right here. Okay, so that you can check it. Then you're going to do another one, and you're going to do this one by hand, and you're going to, just like I sketched this right here, you're going to do that. You're going to sketch it, you're going to put in the secant line, and you're going to put in the tangent line. And you're going to label everything that it tells you to label, and that'll be it. Okie dokie artichokes. I will see you tomorrow.